In this video, we're going to look at some sample problems regarding the hyperbola. So for the first one, we are asked to determine the parts of the graph of the hyperbolas given their equations. Then if possible, we sketch their graph. So let's look at one here. We have x squared over 16 minus y squared over 4. Y squared over 4 equals 1. Now, since we're already in standard form, more or less we can work with this. So first, we determine the center, which as we can see, there's no x minus something or y minus something, so the center is at 0, 0. And since it's x squared, that is positive, then this hyperbola opens horizontally, is horizontally oriented. With that in mind, we can now go to a squared, b squared, and c squared. Now let's just write x squared is positive. Alright, so a squared is the denominator always on the positive term, so that would be 16. B squared is the other denominator, which is 4. And c squared, like we mentioned before, is a squared plus b squared. So 16 plus 4 equals 20. Now we get the values of our a, b, and c. So we have the value of a, which is equal to 4, the value of b, which is equal to 2, and the value of c, which is equal to 2 square root of 5. From there, we can now get the different parts that we have. And to help us analyze, let's draw a rough sketch of our Cartesian field. So the center is here at 0, 0. Now, we are told that a is equal to 4 and that can give us our vertices. Since the hyperbola is oriented horizontally, to go to the vertices, we go to the left and to the right. So that's 1, 2, 3, 4. 4 units to the first vertex. And 4 units, 1, 2, 3, 4, to the other vertex. So therefore, we have here the points 4, 0 and negative 4, 0. Or we write it as plus minus 4, comma 0. With that, we can also now get the measure of the transverse axis, which is from this point up to this point. So that's to the length of the transverse axis instead would be it's 2 times 4, which is equal to 8 units. Now, for the co-vertices, that would now be perpendicular to the direction of where you got our vertices. In this case, that will be going up and down. So that's 1 and 2 for this co-vertex, and then 1, 2 for this second co-vertex. So therefore, the coordinates of our co-vertices would be the first one is at 0, 2, and the other one is at 0, negative 2. Or we write it as 0, comma, positive, negative 2. And then we can look for the measure of our conjugate axis, which is actually from this point up until this point. So that would be equal to 2 times 2, which is equal to 4 units. Now we can get a look at our foci. Our foci is a bit irrational, so maybe we can just try to somehow estimate that. Square root of 4 is 2. So square root of 5 is 2 point something. And multiply that to 2, you're going to get 4 point something. So let's just a hard estimate. This is 4, this is 5. So a very hard estimate would be here. That would be our first foci. That is C. Here you go here. That's right. C is equal to 2 square root of 5. Let's fix this. I'll just write first. C is equal to 2 square root of 5. There you go. And this is f sub 1. If we do the same, fit here, this is your C is equal to 2 square root of 5, and that is your f sub 2. And since it also moves horizontally, therefore the coordinates of your foci is 2 square root of 5 comma 0 and negative 2 square root of 5 comma 0 4 will be positive negative 2 square root of 5 comma 0. Again, the vertices of the foci are collinear given that the foci is not inside the transverse axis. From there, we can now compute our asymptotes. Let's just asymptotes. For our asymptotes, since our hyperbola is horizontally oriented, the slope would be from b over a. Therefore, that will be 2 over 4, which is equal to 1 half. And since the center is equal to 0, we simply use the equation y is equal to positive negative b over x, a positive b over x, and y is equal to negative b over ax. Therefore, the equation of our asymptotes will be equal to y is equal to 1 half x, and y is equal to negative 1 half x, or we can write that as y is equal to positive negative 1 half x. If later on we can try to graph that after we get everything. Now from here we then get our ELRs. Let's go a bit down more. For our ELRs we need e squared over a. So we go up, that's 4 over 4. 4 over 4, which is equal to 1. So therefore, since our conjugate axis, as you can notice here, it's 0 to 0 negative 2, so it's vertical. Therefore, our ELRs will also be vertical. That being said, the ordinates of the foci will be the one added and subtracted 1. And since this is 0, we just need to add and subtract 1 from 0, so that with 2 square root of 5, 1, you go 1 up, and then you go 1 down. You also do the same for the other points. Oops, one should be positive 1, and the other one should be negative 1. If we show that in our illustration here, if that's our focus, then this one here, that point there is our this point here is our ELR, and also this point here is our ELR. And here and here is our other ELR. Now let's try to graph, although it's kind of difficult here already because I have these measurements I can make. Let's go try that. Now if you notice, a while ago, not a while ago, but in the previous video, we have that box. That box should be aligned to our asymptotes because that can serve also as our guide when we sketch the graph of our hyperbola. So that box can be drawn with broken lines, and just to remind you, the vertices and the co-vertices are not corners, they're actually midpoints of the sides of that specific rectangle. So I'll just draw broken lines here. There we go. Broken lines. Because I'm drawing them as broken lines because they're not really part of the graph. Here. Now the graph of y is equal to 1 half x and y is equal to negative 1 half x must pass through the corners of this rectangle. So if I graph y is equal to 1 half x, that the positive slopes will go of 1 and go to 1. So it will somehow look like this line here. And align it. There you go. So the other one, y is equal to negative 1 half x. So I can go up 1, then left 2 here. So this one here and that one there. So these are our asymptotes that can guide our hyperbola. Now to sketch the graph, remember that the ELRs can be used as a guide, as our guide also, although I cannot say that the ELRs are correct because it's 2 square root of 5. So it can look something like this. We pass with the ELRs, then make it closer to D, asymptotes. Something like that. And here, oops, something like this. So we can look something like that. So that is the sketch of the hyperbola at 1a, x squared minus 16 minus y squared over 4 equals 1 with the different parts. Now, what if it's like letter C, wherein it's written in general form? We first need to write this in standard form. So to do that, I'll write all those with the same variables together and those that are constants, place them on the other side of the equation. So this goes here. Therefore, I'm going to have 3x squared minus 2y squared plus 4y equals 26. 3x squared is alone, so that's it. However, negative 2y squared has 4y, and that middle first degree term tells us that we need to complete this square. So to do that, first this has to be 1. Therefore, we factor out negative 2. Hence, we're going to have 3x squared minus 2 multiplied by negative 2y squared divided by negative 2, that's y squared. 4y divided by negative 2, that's negative 2y equals 26. Now, we complete this by dividing this middle term by 2y and squaring it. That's negative 1 squared, which gives us 1. Therefore, I'm going to have 3x squared minus 2 times y squared minus 2y plus 1 is equal to 26. And now that we added something in the left side, we also add something on the right side, but it's not 1 immediately. Because this is 1, but it has to be multiplied to negative 2. So 1 times negative 2 is negative 2. So what we have added on the left side is actually negative 2. And that's also what we add on the right side. Since we added negative 2 on the left side, we add negative 2 on the right side as well. So now the PST, the perfect square trinomial, can be written as a square wave binomial. Thus, we have 3x squared minus 2 times y minus 1 squared is equal to 26 plus negative 2, that is 24. Now to write this in standard form, we divide both sides of the equation by 24. Hence, I'm going to have x squared over 8 minus y minus 1 squared over 12 is equal to 1. And now we use this standard form to get the parts that we need. So first, our center is at 0, 1. It's almost not HK, but it's still HK. Since x squared is the one that is positive, even though the bigger denominator is 12, this is still a horizontally oriented asymptote. With that in mind, we can now get e squared, and c squared. Again, in the hyperbola, a squared is not the biggest. It's the denominator under the positive term. So here, a squared is equal to 8, b squared is equal to 12, and c squared is equal to 8 plus 12, which is equal to 20. Now, getting their square roots, we're going to have a is equal to 2 square root of 2, b would be equal to 2 square root of 3, and c would be equal to 2 square root of 5. Since these are all square roots, it would be too difficult to graph, so we'll not graph them. But still, we can try to somehow visualize using a Cartesian plane how the parts are. Now, the center is at 0, 1 here. Since this is horizontal, therefore, to find the vertices, we still need to move 2 square root of 2 units to the right, and 2 square root of 2 units to the left. And in doing so, that means you need to add and subtract 2 square root of 2 to the abscissa of the center, because it's still at 1. But what will change is the abscissa, the distance from the y-axis of the center to go to the vertex. Hence, this will be 0 plus 2 square root of 2, 1. And then the other one is 0 minus 2 square root of 2, 1, which will lead us to 2 square root of 2, 1, and negative 2 square root of 2, 1. These are the actual vertices. Or, we write them as positive or negative 2 square root of 2, 1. Now, again, but now for the length of our transverse axis, again, that will be twice the length of A, should be equal to 4 square root of 2 units in this case. Now, for our co-vertices, we move perpendicular to how we move to the vertex. So that means we go up and down from the center. That means, in this case, it's the ordinate of the center that we add 2 square root of 3, which is the value of B, and that's also where we subtract 2 square root of 3 from the ordinate of the center. And since that's the simplest form, those are our co-vertices, 0, 1 plus 2 square root of 3, and 0, 1 minus 2 square root of 3. Or, we can write it as 0, positive negative 2 square root of 3. Further, the length of the conjugate axis is twice the length of B, and that will be 4 square root of 3 units. For our foci, we also, this is for the co-vertices, for our foci, we also move to the right and to the left. Hence, for our foci, we again add or subtract from the abscissa of our side. This time, we add and subtract 2 square root of 5 from the abscissa of our center. Hence, our foci becomes positive negative 2 square root of 5, 1. Or, you can write them separate, 2 square root of 5, 1, and negative 2 square root of 5, 1. From there, we can then go to our asymptotes. And our asymptotes, since we have a horizontally oriented hyperbola, our slope is still b over a, which in this case is 2 square root of 3 over 2 square root of 2. Simplifying this, we'll get square root of 3 over square root of 2. Rationalizing this, we go to get square root of 6 over 2. So therefore, our b over a is square root of 6 over 2. Since our center is not n 0, 0, we need to be mindful of the form of the asymptote. So, using this as the point and using this as the slope, the equation of the first asymptote will become y minus 1 is equal to the square root of 6 over 2 times x minus 0. And then the other slope will be the negative, the other equation rather will have the negative square root of 6 over 2. Let's just show the positive one first. Since this is x minus 0, that simplifies to y minus 1 is equal to square root of 6 over 2x. That looks okay and it will be accepted. However, it would be better if it looks like this, meaning this is 0. We can just write it as slope-intercept form. However, we also accept if it's written in point-slope form. So in this case, I'm going to have y is equal to square root of 6 over 2x plus 1. Change that 6 here. There you go. It will also look the same in the other asymptote because just simply y minus 1 is equal to negative square root of 6 over 2 times x minus 0. Y minus 1 will be equal to negative square root of 6 over 2x. So y would be equal to negative square root of 6 over 2x plus 1. So these are the two asymptotes. And finally, for our ELRs, we need b squared over a. So it's 12 over 2 square root of 2. This is 6 over square root of 2 if we simplify. To rationalize, this becomes 6 square root of 2 over 2, which if we simplify is 3 square root of 2. Therefore, in the foci, we're going to add 3 square root of 2. Now, since the hyperbola is horizontal, therefore the conjugate axis is vertical. And since the length of the latus rectum, not the length, the latus rectum is parallel to the conjugate axis, the lateral recta, the two lateral recta of this hyperbola is vertical. Hence, what we have to change would be we have to add and subtract in the ordinate of our foci. Hence, in the first focus, that's not right here, in the first focus, this will then become 2 square root of 5, then we add and subtract 3 square root of 2 from 1. In the second foci, that's negative 2 square root of 5, we also add and subtract 3 square root of 2 from 1. So we can write our foci like this, or we can have all 4, but I will not write it down anymore, or we can have it as positive negative 2 square root of 5, comma 1, plus or minus 3 square root of 2. The graph is a bit difficult, not a bit, it is difficult because all our measurements are in radians. So this is the long solution to find the parts in 1C. This time, we do the other way around. We're given conditions, we're given certain parts of the hyperbola, we're now asked for the equation of the hyperbola in general form. So for A, we have the center at 0, 0, which makes this a bit easier for us. One focus at 3, 0, and one vertex at negative 0. So if it's easier for us to align and to graph the points, at least so we can see them better. This is our center at 0, 0. Our vertex is at negative 2, 0. And one foci is at 3, 0. So this tells us that the transverse axis is horizontal. This also tells us that the hyperbola is horizontally oriented. Apart from this also tells us actually the length of A, because that's from the center to the vertex. So that is equal to 3. A is equal to 3. Therefore, bringing us to the fact that A squared equals 9. The length now of the center to the focus is actually C. A is not equal to 3. That's for the focus. A is actually equal to 2. From center, that's 2. Sorry about that. It's 1. So A equals 2, therefore A squared equals 4. C is equal to 3. 1, 2, 3. So the center to focus is C, so that's C equals 3. Let's make it C equals 3. Therefore, C squared equals 9. But what we need in the equation, especially in the standard form first, is B squared. But we know that B squared is, we know that B squared is equal to C squared minus A squared in the hyperbola. So therefore, we're going to have 9 minus 4, that's C squared minus D squared. And B squared will equal to 5. Now we can write the standard form and then let's return to the general form. Hence, since the center is 0, 0 and it's horizontal, x squared is what is positive. Therefore, I'm going to have x squared over 4 minus y squared over 5 equals 1. To write this in general form, I need to find the LCD, and since 4 and 5 are relatively prime, I have to multiply the LCD is their product, which is 20. Therefore, this becomes 5x squared minus 4y squared equals 20. General form, so I have to transpose this. Therefore, the equation of the hyperbola in general form with center at 0, 0, one focus at 3, 0, and one vertex at negative 2, 0 is 5x squared minus 4y squared minus 20 equals 0. Now let's look at letter B. We are told that the center is at 2, negative 2. The transverse axis is parallel to the y-axis with a length of 6 and a conjugate axis length of 10. If we try to graph this, the center is at 2, negative 2. 2 here. it is also said that the transverse axis is parallel to the y-axis. So therefore, the transverse axis is along this broken line that I'm drawing. This tells us that the hyperbola is vertically oriented. Look, the transverse axis is vertical, and the length of it is 6. Since the length of the transverse axis is equal to 6, this tells us that 2a is equal to 6. Therefore, a would be equal to 3. And that tells us that a squared equals 9. On the other hand, the conjugate axis is equal to 10, which tells us 2b is equal to 10. Therefore, b would be equal to 5, making it b squared equal to 25. And we already got a squared and b squared in the center, and we know that it's vertically oriented. So we can write the equation of the hyperbola in standard form. And since this is vertical and going, I have to write y first. So it will become y plus 2 squared, because that's negative 2 in the coordinate of the center. That's y plus 2 squared over 9 minus x minus 2 squared over 25 equals y. This is the equation of this hyperbola in standard form. In general form, I would have to multiply this by the LCD. And since 25 and 9 are relatively prime, I have to multiply this by the LCD of 225. So therefore, this would become 25 times y plus 2 squared minus 9 times x minus 2 squared equals 225. Now we have to expand our squared binomials before we distribute, before we simplify. So this becomes 25 times y squared plus 2y squared plus 4y plus 4 minus 9 times x squared minus 4x plus 4 equals 225. Then we distribute. This becomes 25y squared plus 100y plus 100. Then we distribute negative 9. This becomes negative 9x squared. Negative 9x squared plus 36x. This is 36 rather, because this is negative 9 times negative 4 minus 36, then I transpose this. Minus 225 equals 0. We combine like terms, and I'm going to let y squared in front because that's the positive 1. Which of 25y squared minus 9x squared plus 36x plus 100y, and then we have 100 minus 36 minus 235 minus 161 equals 0. Therefore, the equation of the hyperbola whose center is at 2, negative 2, and at transverse axis rather, parallel to the y-axis, transverse axis length of 6 and conjugate axis length of 10 is 25y squared minus 9x squared plus 36y plus 36x rather plus 100y minus 161 equals 0.